Welcome back to Forsyth Tech's North Carolina Plumbing Code class. So this is the book we're going through right here. Okay, last class that we had, that you watched the video, was Chapter 2, Definitions. And we covered things like what's the difference between the definition of having access to something and ready access to something. We talked about how does it mean to measure something by developed length? What does that term refer to? We talked about things as far as it talked about building sewer and let's see, the building drain. Where's the junction of the two of those located? A water service, water distribution. What do those terms apply to, and where's the junction of those? All that stuff was found in Chapter 2. So, and then once you watched the video, you clicked on your Chapter 2 and then completed that quiz, a 10-question true or false quiz. At the end of this video, you hopefully will be able to successfully click on Chapter 3 and take that. I've got a 10-question, and that's going to be a multiple choice quiz that you're going to be taking following this one. So I recommend that you wait until you watch the video session and completely watch it through. It's going to give you the best chance for success on your quiz. So go ahead and get out your book, get out your notepad or whatever you've got to take some notes in if you want to take notes there. Just remember, we're not marking up your code book unless you just not planning on using it for your state exam. Otherwise, when you go to take your state exam, they do not want this book marked in. Okay, you can highlight only. No circling, underlining, adding in notes in your margins, anything like that. Okay, so this week we're getting into moving on to Chapter 3, General Regulations. Some general regulations. Now, if you went back to, let's just kind of look at that table of contents. Now, later on, you're going to really use this table of contents a lot. But if you're learning to search for information and you weren't familiar with a book, you could you've got table of contents in the front. You also have an index in the back to where maybe you're looking for a specific wording or term and just say, oh, flood level rim. Where does it talk about flood level rim? And you could look over and see and find what sections does it talk about flood level rim at, okay? So if you had a particular wording, the index in the back, this table of contents kind of takes you through. And so we've been through Chapter 2 with definitions. Now we're moving into Chapter 3, General Regulations. If you look at this one, what are we going to cover? First of all, it's some general information, and then exclusion of materials detrimental to the sewer system, materials, rodent proofing, protection of the pipes and plumbing system components, trenching and excavation and backfill, structural safety, piping support, flood hazard resistance, washroom and toilet room requirements, toilet facilities for workers, tests and inspections, equipment efficiencies, condensate disposal, penetrations, alternative energy in engineered design, carbon monoxide alarms. Okay, so this is the information that is going to be found right there in Chapter 3 that we're going to be covering. Okay, so let's look over. Chapter 3 starts on page 15, as found. What that told us in the table of contents. That's where it was starting. Flip over to page 15, and we'll get going. General. I'm not going to, like I said, like for Chapter 2, I'm going to leave it for you to go back through and fill in the gaps and read. I'm just picking out some kind of important things that I want you to really remember. You can fill in the rest. So we're going to pick up with some conflicts. 301.7, where some information is conflicting, meaning one thing saying something else says something else. What do I do? What do I go by? So it says, where the provision of this code and the conditions of the listing or the manufacturer's installation instructions occur, the provisions of this code apply. So if you purchase something and it had some manufacturer's installation instructions and says the manufacturer says, we want you to put it in this way. Okay. But the code goes and says, hey, this is how we want you to install it. It says that you should be going the provision of this code apply. Okay. Follow the code. But now there is an exception. So always make sure to go down through and follow all the information and look to see if there is an exception at the end of the information. It says where the code provision is less restrictive than the conditions of the listing, the equipment or appliance, or the manufacturer's installation instructions, the conditions of the listing and manufacturer's installation instructions shall apply. So it says basically what you're going to do is you're going to go with the most restrictive. Okay, the most restrictive. So let's just say, for instance, here's a wall, here's an overhang eave of the roof, and you were to take a vent out the side. Maybe that's for a gas stove. This is the outside of the house. Okay, this might be ventilated soffit to where it allows air from the outside to flow up into your attic. Okay, so if the code were to tell you, if we read something in the code, and the code said this vent needs to be at least 12 inches below the soffit material. I'm just throwing numbers and information out there. So if it says that has to be at least 12 inches below, and that's what the code said, a minimum. Maybe you can see that a little bit better. And then it says if the manufacturer said it's got to be 18 inches minimum, which one do you go by? Which one is the most restrictive? If one had a 12-inch minimum and the other one had 18-inch minimum, you've got to go with the 18-inch minimum. Okay? Follow which one. If one said had a maximum, and you read something where the manufacturer said the maximum distance on this was 8 inches, and the code said a maximum of 10 inches, okay, then you're going to go with the maximum of 8 inches, okay? Follow what's most restrictive. Okay. Let's see. I'll let you read the section 302 on your own. 303, materials identification. Says each length of pipe and each pipe fitting, trap, fixture, material, and device utilized in the plumbing system shall bear the identification of the manufacturer and any markings required by the applicable referenced standards. So if you remember installing the pipe under the house, you looked and you saw that there was information stamped along the side. It gives you whether it says it's not for pressure, if the piping is able to hand pressure, it'll give all the pressure ratings on the pipe, the manufacturer, and it gives all that information. It will have the ASTM numbers on there that will give as far as to say what's approved and everything else. So it's saying, but got to have that pipe identification on there. Okay. The exception where the manufacturer identification cannot be marked on the pipe fittings and pipe nipples because of the small size of such fittings, the identification shall be printed on the item packaging or on documentation provided with the item. Okay, let's see. Continue on down. I'll let you finish reading the rest about materials on your own. Get down to section 304 on the bottom of page 15, and we get to rodent proofing. Rodent proofing. Strainer plates 304.2. All strainer plates on drain inlets shall be designed and installed so that the openings are not greater than a half an inch in least dimension. Okay, so if we had some strainer plates, and most of the time you're just buying a strainer plate and you're trusting that the manufacturer had those less than a half an inch opening on those. But that's just where the code is going to state that. Openings for pipe 304.4. In or on structures where openings have been made in walls, floors, or ceilings for the passage of pipes, the annular space between the pipe and the sides of the opening shall be sealed with materials compatible with the piping materials and located for use of collars or caulking materials or gasket systems. Openings for pipes. Okay, so right now, if you're working on, we're working through on the rough end phase of the house. We've got maybe a wall here, okay, and it's all open framed. This is the floor. We drilled a hole up through. We're sending the pipe up, and then we're going to turn out of the wall with a pipe. Vent pipe goes on up. Okay, so we're left with a pipe hanging out the wall. When the drywallers come in, and the drywaller comes in and puts their drywall and hangs that, they're going to cut or knock a hole around this. And let's get any color out of that one. There's the drywall, and it leaves a gap around where the pipe comes through. We've got to have those spaces cleaned off, so sealed off. So if it's too big of a hole, we need them to come back in and kind of patch drywall around there, drywall compound, and seal that off to where it gets to the size of what we'll end up doing is putting a trim ring over this. Okay, so the trim ring is going to go around the pipe, and it's going to fill that gap. Okay, so we've got to have all those gaps around the pipe filled off and closed off, and that falls under rodent proofing. So they'll get you on the final for that. If you say, hey, we're done, we're ready, and they open up your cabinets and you got holes exposed around your pipes to where they can see back into the wall, they'll more than likely turn you down and cite this here saying, this code saying 304.4, you need some rodent proofing there. Okay, now we're going to start to talk about protection of the pipes. Protection them from corrosion. Now, when you think of corrosion, you're probably thinking of something that happens to metal. Okay, you're not thinking about a plastic piping. It says, but pipes passing through concrete or cinder walls and floors or other corrosive materials shall be protected against external corrosion by a protective sheathing or wrapping or other means that will withstand any reaction from the lime and acid of concrete, cinder, or other corrosive materials. The sheathing or wrapping shall allow for movement, including expansion and contraction of piping. The wall thickness of the material should not be less than 0.025 of an inch. So, actually, we can't take our plastic. When we start to run an underground, this is where it gets us as far as talking about where you have to sleeve your pipes coming through the concrete. We don't want that. It says it's not going to allow the lime, the acid of the concrete. We've got for the cinder or other from the cinder blocks and different things that you might pass through. We've got to protect that and have that sleeved. Okay. So, and you'll see that when we do an underground, running the pipes up, we'll have all the pipes protected so no concrete is up against those. Now, how do we protect it from stress and strain? Piping in a plumbing system shall be installed so as to prevent strains and stresses that exceed the structural strength of the pipe. Where necessary, provision shall be made to protect pipes from damage resulting from expansion, contraction, structural settlement. Well, how about with pipes going through underfootings or foundation walls? Any pipe that passes within 12 inches of the bottom of the footing. Okay, let me draw some pictures so we can get some visual representation here. Anything that's going within 12 inches of the footing. So to begin with, they're going to come out and they're going to dig a ditch all the way around the perimeter where the walls are going to go. Concrete gets poured in here, okay? And this is called the footing. Or you hear some people say the footer. Okay. Then this is a good, they're going to come, they get that inspected, the ground underneath this. They will come and you'll see maybe an inspector might come and he might have a compression rod. He pushes down and makes sure that this is good solid ground that the footer is poured on. This concrete footing all the way around gets poured, and then that's what they're going to build their walls up on. Okay. There comes up the block and brick wall for the foundation. And then we build up on top of that. When you were underneath the house and you looked, you saw there was then they put what's a wooden called a sill plate gets tacked onto there. There's actually holes get drilled in that. There's these straps that get anchored down into this foundation wall. Those straps come up and they got little tabs. They'll bend over and they'll nail that down, okay, anchoring this sill plate to the foundation wall. Then they lay floor joists that will bear on top of this and run across and bear onto either the other foundation wall on the other side, or if they need supports in the middle, they'll put supports. And then your wall builds up on top of there. Okay, sill plate wraps this thing. Wall gets built up on top there. And there's your exterior wall. And there's then your floor system gets built up on top of this, okay? This is this crawl space in here. Okay, so this is talking about, it says, if underneath, if we sent a pipe coming within 12 inches below that footer, it's saying all this weight of the house is bearing on this exterior wall, and they just don't want any type of pressure pushed on that pipe. So it's referring to a pipe that's coming here, okay, within 12 inches of the bottom of the footing, or through a foundation wall. So it says, or we could have something coming through the foundation wall. Maybe you've got, this could be all below ground. When this gets all covered up, that could end up being your ground level on the outside. So this is the ground level here. Okay, right here. So you might have a pipe that actually stays below the ground, but is going to come through a foundation wall. So either through the foundation wall, it says, shall be provided with a relieving arch or a pipe sleeve. Okay, we want a pipe around it to protect it. Pipe sleeves for foundation wall should be built into the foundation wall. The sleeve shall be 2 pipe sizes greater than the pipe passing through the wall. Okay, so it says we can't just run our pipe through. What we've got to do, we've got to put a sleeve on this. So we're going to make a sleeve. We could sleeve it under there, or relieving arch, some type of half round thing. But we have to sleeve this, okay, to where the pipe passes through the sleeve. It says that sleeve, if it's in here, it needs to be built into the wall. If a hole was knocked, it needs to be concreted back around to where that pipe is solid in the wall. Now, we're not concerned about the concrete going up against the sleeve. We're not worried about the corrosion that might happen onto us, where that would become brittle. The sleeving, that is protecting the actual pipe. So even though it says on 305.1 about, oh, we can't have, concrete up against pipe. Well, it's not up against our pipe. It's up against the sleeving pipe. So that's fine. Okay, so we have it sleeved in. Then it says what size sleeving is required. Okay, so let's just say this was a 3-inch PVC drain line going out of there. It says we need to go up 2 pipe sizes larger. You say, well, how am I supposed to know what the pipe sizes was? How do I know what 2 pipe sizes larger than 3 is? Well, if you don't remember, one of the things that we've already covered in chapter 2, you can flip back to your definitions and look for under the P's and look for the P pipe size, page 10 of your code. So if you look at all the pipe sizes that they're labeled out there, goes from starts at a half an inch, goes half, 3/8, 1, 1 1/4, 1 1/2, 2, 2 1/2. Oh, 3. 3 is the pipe is the size we're sleeving. Go 2 pipe sizes larger. 1 pipe size up is 3 to 3 1/2, and then that's 1 pipe size. 2 pipe size goes up to 4. So 3 1/2, then 4. So what size would this sleeve need to be? A 4-inch sleeve. Okay, so to sleeve for that 3-inch pipe, we need a 4-inch sleeve going through there. All right, let's go back to 305.3. That's where it was. Okay. It also goes through and says that piping shall not be run under pier footings. So if on the inside here, if they pour another footer, okay, here's another footing or footer. So that's concrete across in there. And then they're making this coming up. And they just block that. Okay, they put some blocking in there. And that's going to have a load on it. And they call that a pier. Okay. And it says they do not want us to run a pipe. This is not allowed. We're running a pipe underneath the pier footer. So it's really only wanting you to put pipes underneath footers absolutely when you have to, and then sleeving them when required. Okay. 305.4. Now, how about protecting them about freezing? We don't want those pipes to freeze. What do we got to do for that? Water pipes installed in a wall that's exposed to the exterior should be located on the heated side of the wall. Insulation. Okay, you can pause and get down, draw out any of that if you want to, if you need. Get rid of that out of there and move on to the next thing. So this is saying floor. Okay, there's our foundation crawl space. Floor joist is on there. Okay, but let's just we'll just go from here. Here's your wall going up. All right, floor, exterior wall. If we have a line, so let's just say we have to put a water line coming up this wall, and it's going to stub out of the wall right there. Okay, but this is the outside. That's an exterior wall. We need to have that water line as far to the inside as possible. When the insulators come in, they need to put this insulation in here to where our water line is pulled to the heated side of that. Okay. We want to make sure that they can put that insulation back in there loosely. If we ran and just say, well, hey, yeah, my water line's way back there close to the back of the wall, but they could still kind of shove it and tuck it back there. If you compress the insulation, it loses that R value, that insulation value that it has for protecting it. So we need to keep that water line as far forward as possible when we run it in an exterior wall. You'll notice that on when the homes we do, that we'll actually take and we'll wrap insulation around that line. We'll do that when they might have blocking back in the wall. Okay, so maybe they're putting some blocking in the wall for cabinets. So let me blow up the wall here. There's the thickness of the wall. And some of this space is taken up because they've got a 2x4 block between, you're looking at it from the side end. So this block is going between a stud and a stud. So that's taken up 1.5 inches of the 3.5-inch stud. So our water line is going to have to actually flex and go behind that. Okay. So once we flex the water line and we have the water line running behind the block, it's not enough area to get insulation in behind here. So what we'll do is we'll pipe wrap that water line to keep that thing from freezing. All right. Let's see what else it says, how to protect them from freezing. Now that's water lines, water pipes. Water, soil, and waste pipes shall not be installed outside of a building. Don't put them on the outside. In unconditioned attics, unconditioned utility rooms, or any other place subjected to freezing temperatures, unless adequate provision is made to protect such pipe from freezing by a minimum of R6.5 insulation determined at 75 degrees in accordance with ASTM C177. Okay, so you can get insulation to pipe wrap them if you needed to. It says, or otherwise, leave them out of those areas. We don't want anything freezing. Okay, the next little phrase there, exterior water supply piping shall be installed. And it's talking about in the ground here. So if I asked you how deep do you need to bury a water line in the ground outside the building? Okay, it says installed not less than 6 inches below the frost line and not less than 12 inches below grade. Ground level. There's the ground. And I say, well, if we're going to run a water line, how deep of a ditch do we need to do here? If we're going to run this water line, there's our water line. The rule is 6 inches below the frost line, but no less than 12 inches. Okay? So it's not a fixed number. So remember when you go to take your exam, that you need to look for the option that says 6 inches below the frost line, but a minimum of 12 inches. Our frost line in this area is 12 inches. Okay. So the rule says part 1 is 6 inches below frost line. So there's kind of two parts. Part 2 says no less than 12 inches deep. Okay. So our area of frost line, you got to know and find out what your area of frost line is. For our area, we got a 12-inch frost line. So you say 6 inches below that is going to put you at 18 inches down. 18 inches down in the ground, minimum. Okay. It says that meets part 1, but no less than 12. Is 18 less than 12? You said, no, it's not. It's greater than 12. So good. You're good to go. 18 inches good. Most of our areas, so we get so used to thinking 18 inches, 18 inches, 18 inches down. And every time I ask you, how deep do you need to bury the water line in the ground? 18 inches. Well, yes, 18 inches is correct for our area. Okay. So just be aware that as you maybe you go to the mountains, let's just say their frost line is, if their frost line is 14 inches or 18 inches or something, you've got to go 6 inches below that. Okay. So if theirs was 16 inches, they had a 16-inch frost line, then you got to go 16. Okay, what is that? 16, 17, 18, 19, 20, 21, 22. Add 6 inches below that. So 22-inch going to be how deep in the ground do you need to be? Maybe you went down to the coast. Down the coast, maybe they say, our frost line down here, we are only freezing 4 inches deep. So we don't ever have it freeze less than that. So 6 inches below the frost line. And then you add, which is a 4-inch frost line. So that's going to give you 10 inches down. That meets part 1. But part 2 says, but it can't be less than 12 inches. So you're going to always have to you can't let that number be lower than 12. You're going to always be at least 12 inches in the ground, but your frost line might push you further. Okay, so resist the temptation. You're going to get out and you're going to be so used to putting water lines at 18 inches that on your state exam, don't jump for the number that says, if they give you the choice, 18 inches, do not answer that question 18 inches. That's only good for our areas. The correct is 6 inches below the frost line, no less than 12. It just happens to be 18 for a good bit of North Carolina. Okay. Let's see. Sewer depth. That's for the water line. The sewer, let's just say the sewer line's coming out here. How much dirt do we need on top of that? 3 inches. If this is the sewer line, 3 inches of dirt's all that which we need on top of there. Waterproofing the openings. Joints at the roof and around vent pipe should be made watertight by the use of lead, copper, galvanized steel, aluminum, plastic, other types of flashing or flashing materials. Exterior wall openings should be made watertight as well. Anytime we send a pipe through, we need to seal it up and make it watertight. When we go through the roof, we're going to put a roof flashing on there and make that watertight around that pipe. Protection against physical damage. Okay, so when we're installing those lines, remember all the water lines, anything that's plastic, as you read this section, it'll say for plastic water piping, anything other than metal. Here's the floor. Here's the wall. Here comes our pipe up through. There's our pipe. There's our wall. So it's saying, this is a stud here turned on its side that you see. What it's referring to is how much room do we need from the edge of the pipe here to the edge of the framing member, okay, to not have to put a protective shield plate. So if this area in here is, and it will say less than 1.5 inches, less than 1.5 inches, and that goes for this side as well. Okay, if that's less than 1.5 inches, you have to put a protective shield plate. Okay, it says that if the shield plate, such plate shall cover the area of the pipe where the member is notched or bored and shall extend not less than 2 inches above the sole plates and below top plates. So if this is going through, let's just say that's the top of the wall and the pipe goes on right up through to the attic, we'd say we've got to put a plate here. Now this plate gets nailed to the side of the stud, and where it comes through when they say the sole plate, there's a wood board. The stud gets nailed on top of the to a 2x4 that's laying flat. You've got a 2x4 up here that's laying. Often to support load, those will be like two of them together. It's called a double top plate. When you nail these plates up there, it's got to extend, and you'll see this will go down. It's got to extend at least 2 inches above the sole plate or below the top plates, okay? So that would be, and you'll see that on the job site, and I'm going to have you go through and we'll look at all that, and we will nail those plates up there. If you go through the side of a stud, maybe here's your wall and you're looking at from the front. You've got a stud here, stud here, stud here, and our pipe comes up through, and the vent goes on up through. We've got a pipe that runs through the stud, okay? We've got a protective shield plated if it's closer than 1.5 inches to the edge of the framing member. And this shield plate only has to cover that 1.5 inches, just the amount where the pipe is going through would be fine, okay? It gives you the plate thickness as well that's required on those. All right. Let's look at trenching Excavation and backfill. Trenching, excavation, and backfill. Basically, it says when you dig the bottom of the ditch, you need to dig that out to where it's going to form right to the bottom of the pipe. Okay. It even gets down to the nitty gritty with it to say if you're using cast iron pipe and it's got a bell on the end that looks like that. Okay. It says to dig out a little notch in your ditch to account for those bells. So all the weight of the pipe's not sitting up on that little bell. Okay. It makes little notches for those. It says your bottom of the bed of your ditch ought to conform right to the bottom of the piping. What you want to be careful for of also when you're digging is you don't want to over dig for the ditch and then just dump loose dirt back in, because that loose dirt is going to end up settling out on you over time as you so if you dug a ditch but you're not too good a digger and you dug and you're like, man, it's supposed to be laying a pipe in there. We lay this pipe across and you say, boy, the pipe doesn't conform well to the bottom of the ditch. That pipe is going to end up sagging. It's plastic pipe. This pipe is going to end up conforming to the ground. Okay. You're going to dump all this extra dirt and cover this thing up, and you start to put hot water down through there. It softens, and over time, it can't handle the weight. It's going to bend. So now you got places where you can form clogs because it's doing it. So it says, we got to make that a nice continuous bed for it. So we don't want to also just say, oh, well, don't worry, I'll just shovel a little bit of loose dirt into those areas. There we go. I got them filled up now. Nice loose dirt, because that loose dirt's going to settle out as well. So if you over excavated 306.2, it says the trench shall be backfilled to the installation level of the bottom of the pipe with sand or fine gravel. It tells you can't even shove the dirt back into the ditch that you put in there before. It says now you got to go sand or fine gravel, because you can't compact those like you can just regular dirt. It says put them back in there in layers of 6 inches deep and shall be compacted after each placement. So as long as these aren't deeper than 6 inches, you can put sand or fine gravel, pack it down, and you're good. If you went over 6 inches, just say that went deeper, you got to put 6 inches, pack it, 6 inches maximum, pack it, and keep filling back up and packing it, getting that thing tamped really good. They got tamping machines, they got plates on them. They'll sit there and just and vibrate away and really just pat that down. Now you also see guys with their excavators, they'll take that bucket out there and sit there and just take it and bump it up and down and try and pack that ditch back in. Okay, if you over excavated. So sand or fine gravels, layers of 6 inches, compacting in between. Rock removal. You start to dig a ditch and you're trying to lay a pipe in there, but you can't encounter rock and start to hit that. You've got to remove rock to an installation level of 3 inches below the pipe. We don't want to scrape it out and then just say, and then lay our pipe right on top of rock. If it's up on top of rock, we want to remove that, the rock to no less than 3 inches below the installation level of the bottom of the pipe. Okay. Let's see. If you backfilling, once again, you're going to be loose earth free from rocks, broken concrete, and frozen chunks should be placed in the trench in 6-inch layers and tamped in place until the crown of the pipe is covered by 12 inches of tamped earth. Okay. So it's saying, okay, you've got a nice bed now. Nice, even, level supporting ditch. If you had some rock under here, that was a rock. You've got at least 3 inches minimum of good dirt built up on top of there. A good solid thing, free from dirt. It says, now, There was construction debris on the site. You've got some gravel that was in there that got mixed in with the dirt. There's chunks of masonry in there. We don't want to grab any of that and dump it in here on top of the pipe. So we got to make sure that we've got good dirt that's going to come back in. And here's the crown. The crown's the top edge of the pipe. We've got to go up from that. You're going to fill dirt in here around the sides and on up. Maximum 6 inches layer, kind of packing it as you go until you get at least 12 inches up on top of there. With it's all free from construction materials, rocks, chunks of masonry, some brick and stuff like that might be in there. Then you can start to dump some of the stuff on top, because now you got this nice cushion layer of 12 inches of good dirt up on top of it. Okay. Bringing it backfill should be brought up evenly on both sides of the pipe so the pipe remains aligned. All right, tunneling talks about that. I'll let you read that on your own. Structural safety. Structural safety. That's going to refer you over to 307.2. It talks about cutting, notching, and boring holes in framing members. That refers you to Appendix C. So the information in there, it says, refer over to Appendix C there on page 17. Your appendixes are in the back. There we are. Oh, Appendix C, page 125. Page 125, structural safety. There's the rules there. Now, it's all in written form now. In your in the residential building code, you get a little bit better description of this. It used to have some pictures. We love pictures to go by. The only thing better is if it was in a pop-up book for us. But now it's just we just got to understand the written word. We got to kind of form a mental picture in our mind as we read this. Okay, but it says, all right, we don't want to just go in and start slapping holes wherever we want to place them. We got to be a little bit more careful in that. We don't want to compromise the structural integrity. That wood is there for a reason. It's either supporting the floor, supporting walls, supporting the roof, and we go drilling too much and taking it out, we weaken the system. Okay, so refer over to Appendix C, and it will tell you what can you do. Notching in a joist. Well, first of all, you got to know what a joist is. So what's a joist? All right. You got floor joists, ceiling joists. But let's just say there's our floor. Here's a joist. Could be a soft, and all this stuff talks about solid joists, solid wood. Okay. The Habitat homes that we're plumbing up using TJIs, you got to look at their load requirements as far as what will they let you do with their floor joists. This is solid wood. Okay. It says notches on the ends of the joist shall not exceed 1/4 the joist depth. Okay, so notching it can't be more than 1/4. Holes bored can't be within the top or bottom 2 inches. So take off the top and bottom 2 inches. The holes have got to be somewhere in between there, not into here. Now it says that the hole or a notch can't be, you can notch out the top of the 2, but it's got to be a notch, okay? And it can't be over the 4th. Now that was on the ends of the joists for a 4th. You also have notches in the center portion shall not exceed 1/6 of the depth. Okay. Then it talks about stud cutting and notching. Exterior walls and bearing partitions, any wood stud is permitted to be cut or notched to a depth not exceeding 25%. So if you've got a stud which goes vertical, you can put a notch in it, but not more than 25% of the depth. Okay. Bored holes. Now you've got a stud and you're going to bore a hole. Okay, I'm going to put a hole in it. If this stud is non-load bearing, now so meaning it's all it is just acting as an interior partition, a barrier. It's not really supporting any load of the house and no weight of the roof. So non-load bearing, this hole can be 60%. You can drill a hole 60% of that size. If it's load bearing, that hole can be 40%. Okay, and we'll talk more about this. We'll actually figure up percentages and say what would tell me more than a percent. You know, give me a number. Tell me what that is, and we'll figure that up later. But just so that you know, this is the area that's talking about this. This has got some rules for it that I just can't drill any size hole that I want to. We've got some percentages. This load bearing, that does have an exception to that. It will go on to say that you can go up to 60% as long as you double the stud and you don't drill through more than two studs in a row. Okay. Let's see. We'll leave it at that for now. Oh, the edge. If you drill, here's another stud. You're drilling a hole. It tells you how much wood needs to be left from the edge of the hole to the edge here. That's 5/8 of an inch minimum. You've got to leave. You got to leave at least 5/8 of an inch from the edge of the hole to the edge of the stud. Okay. There you go. Let's go back to, I really want to try to get through this chapter. Okay. 307.3 talks about penetrations through the floor and through the ceiling. So when this goes down through the floor and we have a pipe going down through the floor, we are going to have to seal around that with fire caulking. We don't want to have a draft going from low to high, and you're going to, the fire started off underneath in the crawl space. If there's a draft coming up through, it'll suck the flames right up and spread that to the fire through the main level and up into the attic. So we fire caulk between floor levels, from floor to ceiling, all around our pipes, drain lines, water lines, all of that. Okay, and we'll be doing plenty of that. Okay. Protection of the footings. We showed you the footing before. Remember, you drilled the footer. Remember how the ground level was up here? We dug down, put the poured concrete footer here to protect this 45-degree angle away. That's at a 45-degree angle. We cannot get into this dirt under this hashed area in here is providing structural this strength for that footer. If you dug down into here, we're now what's called undermining the footing. We're weakening that footing. So come from the corner, 45-degree angle out. We can dig our ditches out into here. We cannot let our ditch come down into that area there. Okay. Pipe support. I'll let you read all of that. What I want you to really look at is the hanger spacing table on page table 308.5 right there. 308.5, there's your hanger spacing table. I want you to really be familiar with that. What we've talked about, the ones that you're getting used to, is the PVC. I ask you, what's the maximum distance between hangers on the PVC pipe? Now, everything we've been running so far is horizontally run PVC pipe. So you look at your chart, you find the material over on the left side and said, okay, we've been running PVC. So we drop down to PVC, polyvinyl chloride, horizontally run pipe, maximum of 4 feet. If we turn the pipe vertical, we can go a maximum of 10 feet between supports. Look at your little notes. When they have a chart, there's little notes at the bottom. If there's a letter beside the number, which there is in this case, it says a B. It says for pipes, drop down to the bottom of the chart and read it. For sizes 2 inches and smaller, a guide should be installed midway. Okay. So if we had a pipe that was passing, so there's our pipe. Let's just say there's the top plate of the wall. There's the bottom where it goes through. This gap is going to be, okay, which we call 1 story if it's about 8 foot in between. If the pipe is 2 inches and smaller, it's going to want us to put a strap somewhere here in the middle. Okay. If we get up to 3 inches and bigger, we don't have to put that, but it states that there. So it's looking, you're saying, oh, well, it's supported where it goes through the floor, supported where it goes through the ceiling. That's only 8. This says we can go up to 10 feet, but it says if it's smaller, you got to put a strap right there, okay? So you can just find it. Find the material you're dealing with. Some of them, if it's CPVC, there's one that says if it's in 1 inch and smaller. There's one here that will say if it's 1 1/4 inches and larger. You got to go with those, okay? First one is horizontal pipe. Second one is if the pipe is going vertical. We're going to use a lot of PEX piping. So how it's a horizontal supports between PEX, 32 inches. Okay, that's how you're reading that chart. Let's see. I'm going to let you read flood hazard resistance, washroom and toilet room requirements, toilet facilities for workers. It is required by code that toilet facilities should be required for construction workers. Construction worker toilet facilities of the non-sewer type shall conform to, if you've got less than 20 employees, got to have 1 toilet. 20 to 200, 1 toilet, 1 urinal per 40 workers. More than 200, you got 1 toilet, 1 urinal per 50 workers. Okay. There should be at least 1 facility for every 2 contiguous construction sites. Okay, so basically you're having to have temporary toilet facilities on sites. They've got to be temporary toilet facilities need not be provided on site for crews on a job for no more than 1 working day and having transportation readily available to toilet facilities. So we're only popping up for work for 1 day. Hey, don't have to provide them. Okay, the last stuff I've got, 8 minutes to cover it real quick. Testing and inspection. Once we get all the pipes run, we got to cap everything off. We got to test it. Okay. It says we got to test them according to these. It even gets into the type of test gauges that you use. You can't use if it only requires a 5 PSI test, you can't use a 100-pound test gauge because the increments are too small to really get a good read. So it talks to you about the test gauges, drainage and water and vent water test. If you're putting a test on the drains and vents and you're doing a water test, drain and vent, drains, vents, you can do, so this is for testing, on for a water test, you've got to have a 10-foot head of water. Okay, drains and vents, water test, meaning you're going to have to fill a pipe. You got all these horizontal pipes going different ways, but you're going to have to go to the most upstream, run you a vent up, and then turn. That pipe has got to go at least 10 foot high and fill all this with water, and that water level is going to have to go up 10 foot. Okay? We're going to just run it right out the roof. But that's what it says. If you're putting a water test in there, it's got to be at least 10 foot. They will let you get by with, if you're doing a add-on, a little remodel or something like that, and you say, hey, there's no way I'm going to get this out of here. I'm just adding on a little island section. I can't stick a 10-foot pipe. That would be somebody's existing house. They will let you come up 3 foot and make provision for that. On new construction, they're going to be looking for that 10-foot head. Okay, so if you read that and was confused, it says something about going up 3 foot. Well, that's what it is. If you put an air test, in this system, it's 5 psi. That's all it is. It's if you looked at the pipe, it says not for pressure. It's just a 5 psi is all that you need on that. Water lines. That's for drains and vents. We got water lines. We do a water test. Is minimum 100 psi. If we air test, 100 psi. All of these tests must hold for at least 15 minutes. Now you say, oh, it just holds for 15 minutes. That's all it's got to hold for and let it off. No. Well, we've got to have it on pressure for 15 minutes before the inspector shows up. He wants to see it holding. It should hold for however long you put the test. Water should never leak out of it, okay? But we've got to have the test on for 15 minutes. The inspector doesn't want us just to say, well, wait just a second, hang on. We top it off real quick and say, quickly look at it. You don't see any leaks, okay, and then we just let it back off. Sometimes it might, if you got a small area leak, it might take a little while for water to start show up. He wants to make sure it's been on for at least 15 minutes. If you got a leak, it's going to have showed up by then. Okay. There we go. I'm going to let you carbon monoxide alarms. So if you're putting in fuel-fired appliances, fireplaces, putting your gas water heater in, it's talking to you about using, you have to have carbon monoxide alarm just now. So read over that information. It will also talk about shower. Let's see if I put that on the quiz about shower liners. I don't on this go round, but it will talk about the liner, the pan test, and everything else. You may want to read over that if you're interested in putting in a tile shower. Okay. In the 2.5 minutes we got left, let me cover what's going to be and review over what's going to be on your quiz real quick. Question number 1, when you install the water pipes underground outside the building, how deep in the ground do they need to be? And we drew a picture up there and we said, when installing water lines in the ground, there's 2 parts. You got to be at least 6 inches below the frost line, being no less than 12 inches. Okay, that was question number 1. 6 inches below frost line, but no less than 12 inches. Number 2, where do you need to use protective shield plates? Where have you got to put protective shield plates? If you remember, if it's when the edge of the pipe and the edge of the framing member, when that gap between the two is less than 1.5 inches, you've got to put a protective shield plate. That drywaller comes and runs his drywall screw. We don't want it to go into your pipe. If it's over 1.5 inches, his screw's not going to be long enough to hit the pipe, so you're okay. Number 3, when trenching, how far does rock need to be below the installation level of the bottom of the pipe? Remember, we drew the picture over here, the trench. We talked about over-excavating some, but we said it drew a picture of a rock down here. How much lower does that rock need to be below the bottom level of that pipe? 3 inches was the answer to that. When boring, number 4, when boring a hole in a joist, how close can you come to the top of the bottom of the joist? We drew a floor joist and we said, you got to stay out of the what? The top, how many inches, and bottom, how many inches? When you drill that hole, can't be any closer than the top or bottom 2 inches was the answer. Number 5, what is the minimum distance required from the edge of the bore hole to the edge of the stud? We drew this as a picture on there as well. How far? We drew the stud, drew the hole, and said, what was this area? From the edge of the hole to the edge of the stud. Got to have at least what? 5/8 of an inch. 5/8. A waste and soil pipe leaving the building's got to have how much inches of dirt on top of it? Covered that right at the kind of beginning of the video. We showed the water line depth, and we said if the sewer line was coming up, how much dirt did we need? We showed that of only 3 inches of dirt was all that was required. 3 inches of dirt. What's the maximum horizontal hanger spacing for PVC pipe? So you went to your hanger spacing table and looked at that PVC pipe listed on the left, one column over where it says horizontal pipe, and it says 4 feet was the maximum spacing. Next question, number 8, is what's the maximum horizontal hanger spacing for CPVC pipe that's 1 inch or smaller? So there's two. Remember, look at the chart. One's for 1 inch or smaller. One is 1.25 inches and up. So the 1 inch and smaller is a 3 foot maximum, 36 inches maximum. Number 9, when doing a water test on the drainage and vent piping, how long does water need to be kept in the plumbing system before it can be inspected? So you're water testing the system, and we said for how long? How long does it need to be in there before it's inspected? And I made that little note over here. We said for at least how many minutes? 15 minutes was the answer. And your last one, what pressure is the water distribution system tested at when conducting a water test on CPVC pipe? What pressure is the water distribution, so not the drainage system, which would have been 5 psi if it was the drainage system, but I'm asking you the water distribution system, the water lines. They've got to be on test of at least 100 psi to be a test on that. And that was it. So hopefully that makes it real easy when it comes to taking time for your quiz. So go ahead, get all that down so you got it all ready. Click on your chapter 3 for that general regulations quiz. Take that and you'll have that knocked out. So I hope you have a great week, and I look forward to next week when we're going to jump into chapter 4 about the 4 F's: fixtures, faucets, and fixture fittings. The 4 F's for chapter 4. Look forward to covering you with that next week. Till then, have a great day.